Okay, so we're going to go over section 3.4, which is exponential and logarithmic functions. And we're just going to continue practicing solving them. Okay, so if I look at example 1a, I have 2 to the x power equals 32. I need to solve that for x. So I need to get my bases to be the same. So 2 to the x equals, and 32 is the same thing as 2 to the 5th power. Very good. And then I know by my one-to-one property that if my bases are the same, that means my exponents are equal. So I know that x then would equal 5. Okay, if I look at example 1b, I have the natural log of x minus the natural log of 3 equals 0. Okay, so then I need to get this to the other side. So I'm going to add the natural log of 3 to both sides, making those cancel, so that I can get the natural log of x by itself, because I'm always trying to get x by itself. So I get the natural log of x equals the natural log of 3, which again, by my one-to-one property, tells me that then x equals 3. Okay, if I look at 1c, 1/3 to the x power equals 9. So I'm trying to get my bases to be the same, so I'm going to try to get a base of 3. If I bring that 3 to the top, then I know that that changes my exponent to be negative, so I get 3 to the negative x. And then I know that 9 is the same thing as 3 to what exponent? Squared. So one-to-one property tells me that those cancel, so I get negative x equals 2, which tells me x equals negative 2. Perfect. Okay, so look at example D. I have e to the x equals 7. And whenever you're trying to get rid of a base, we're going to take the log of that base. So log base e of e to the x, and I'm going to do the same thing on the other side. So log base e of 7, because that helps keep each side of my equation balanced. Okay, and log base e is actually natural log. So I'm going to take natural log of e to the x and natural log of 7.
Wait, so log the base b, that's natural log?
Mm-hmm.
Okay.
And then I know by my one-to-one property that the natural log of e cancels, because just like these e's would cancel. So I know that I get x equals natural log of 7. So that's how you take whatever log to that base, because then you're going to get your bases to cancel. But whatever you do to one side, you have to do to the other side. Okay, so I have natural log of x equals negative 3. This is like log base e of x equals negative 3. And if I want to get rid of that log, then I'm going to take everything. I'm going to make this my new exponent. And I'm going to make e be my base. So I'm going to have e to the log base e of x equals e to the negative 3. I'm making everything be an exponent, because then my e's cancel. So I get x equals e to the negative 3. Okay, we're always looking to try to cancel whatever's with our x. Okay, so if you do the same thing with my log of x equals negative 1, this is like log base 10 of x. as if it doesn't have a base, and it's always base 10. So I'm going to make 10 be my new base, and these be my exponents. So 10 to the log of x equals 10 to the negative 1. So then those cancel. So I get x equals 10 to the negative 1, which is the same thing as 1 over 10. Okay, let's do a couple more. Alright, so I'm given e to the negative x power equals e to the negative 3x minus 4 power. Okay, so I know my bases are the same, so they go away. So I'm going to get negative x squared minus 3x minus, negative x squared equals negative 3x minus 4.
You would add x squared.
Yep, we're going to add x squared to both sides. So then we get 0 equals x squared minus 3x minus 4. Let's factor. So I'm looking for factors of 4 that subtract to negative 3. 1 and 4. So 1 minus 4. So I know that I'm going to get x plus 1 and x minus 4 to be my factors. And so if those both equal 0, then I just set them equal to 0. So x plus 1 equals 0. X minus 4 equals 0. Which then tells me that x equals what? Negative 1 and 4. Perfect. Okay. Let's do one more, and then you guys can get started. So I'm giving 3 times 2 to the x power equals 42. Okay, so I'm going to work to get my x by itself, so what do we think we need to get rid of first? Divide by 3, perfect. So we'll divide both sides by 3. So that those 3's cancel. So then I'm given 2 to the x power equals, what's 42 divided by 3? 14. Okay, so I get 2 to the x power equals 14. Okay, it's impossible for me to change this to a base 2, because 2 to some power isn't going to give you 14. So then we're going to take logs of each side to get rid of it. So what is going to be my base for my logs? 2, perfect. So log base 2 of 2 to the x and log base 2 of 14. So then those cancel. So we get x equals log base 2 of 14. You can just leave it like that, or you can plug it into your calculator and round to 3 decimal places. Okay, so we're just looking at manipulating and solving some logs and exponential functions today. I'm going to do 251, 13 through 24, and 29 through 36.